excited to have you here. Today's topic is Terraform at scale, and I'm very excited to be discussing it with Tylor and Mishra. Just for a quick introduction, Mishra is a book author for Getting Started with Vault, which I can't wait to read. And he's also the technical advisor to the CTO at HashiCorp. Hi, Mishra, and thanks for joining. Do you mind giving us a quick intro?
Yeah, I'm excited to be here. Thanks, Omar, for organizing this. I really appreciate it. This is, I think, my first room that I'm, I guess, a contributor to. I know Tylor has done a bunch of other Clubhouse rooms. So I'm super excited to be here. So as Omar, you beat me to it. I am the technical advisor to the CTO. So I work in the office of the CTO on strategic initiatives that might be some open source work, might be working with our partners like Amazon, Google, and Microsoft on various things. I do contribute a lot to open source. So I've done a bunch of projects. You may or may not have used it in your day-to-day. I'm also the creator of a project called Atlantis that helps you collaborate on infrastructure using Terraform. I've also done a few contributions to a few CNCF projects, but more recently, I've been working with a project called CDK for Terraform, which is bringing in the AWS CDK constructs into Terraform. So I focus on various, various things at HashiCorp, but my true kind of passion is open source and developer advocacy.
That's a very exciting job. Thank you, Mishra. We also have Tylor here with us. Tylor is the Kubernetes release lead for version 1.19, and he's also a developer advocate for HashiCorp. Thank you, Tylor, for joining us, and please take it away for a quick intro.
Absolutely. So, no, thank you so much for the introduction. Very excited to talk with everyone, mostly around community, Terraform, just really anything that y'all have to or wants to talk about. In a life former to Terraform and HashiCorp, I worked for Disney Studios. I've gotten to work in the healthcare space. I've gotten to work with a few big brands like American Greetings, and really just had a very fun and very colorful technology career, and just kind of jumping from vertical to vertical, and really didn't. It was kind of happy. My venture to open source is really unique in the sense of starting out on .NET and VB6 and all those fun things on that front, and then just kind of finding my way, eventually making my way to open source technologies and communities. I'd say the Kubernetes community is one of the first ones that I really found a home in, and found a lot of good friends and fun people to engage with within that community. I've started to get into Go and some people, and dealing with some people on that front, so that's a lot of fun. And then just like Mishra said, just discovering Clubhouse and finding that as a really fun avenue to chat with people as well. So again, very, very excited to be here and happy to have a conversation with y'all today.
Thank you, Tylor. So just a quick intro about myself. I'm Omar. I'm an infrastructure engineer working in the insurance sector. We handle a lot of users, actually in the millions, and my role usually revolves around migrating infrastructure to public cloud. So I've been always a user to Kubernetes, but I've also been someone who loves to dig into the source code and the changelog and the release notes and such and such. I also am an infrastructure lead for a Canadian startup where we've been running Kubernetes for 2 years, and we've been users for Terraform for roughly a year now. So again, thank you all for joining, and I hope you find this useful. So let's jump into the fun stuff. Let's start by talking about the goals of hopefully this conversation with Tylor and Mishra today. I'd love to address writing clean Terraform code and how this would help you scale. And I'd also like to know more about refactoring techniques and pitfalls, and how CICD for Terraform might look like. So please feel free to raise your hand if you have any questions or you have any comments. This talk is primarily for you, or this chat is primarily for you. So Tylor and Mishra, I have the first question that I have for you is something that I'm personally very interested in, which is the intersection between software engineering principles and the DevOps. And both of you seem to have a lot of contributed a lot of code to the open source. So I'd love to know more. What do you consider a clean Terraform code? And when you're reviewing the Terraform code, what is considered the code smell?
That's a great question. Taylor, you don't mind if I go first?
No.
Okay. So I think this is exciting because this is a great question, an exciting topic. Because I think it's like often people just brush over the details where when we talk about infrastructure as code, it is a unique thing. It didn't exist. If you go back 10 years ago, it was mostly made up bash scripts and Perl scripts that got us through a lot of the years in operations. So bringing in some of the software principles into Terraform, into infrastructure as code in particular, has been transformative for a lot of different folks, like all the way from folks that are small startups to larger size companies. The things that I would like to kind of talk about are the ones that I think, as I said, like I often brushed over when someone reads through some of the marketing material that exists on infrastructure as code. So, the goal of Terraform was to kind of bring in, that idea of that you can write all of your infrastructure resources in plain text files, right? Able to describe them in plain text files in a way, in a language that humans can actually understand. And once they are described in that way, you can share that information in your organization, just like how you share code, right? So the idea was to bring in some form of like maybe a subversion system for your infrastructure code, being able to share that in the form of modules or libraries in your organization, and then folks being able to consume things that maybe the operation folks write, and developers kind of being able to just consume that without understanding too many intricate details of infrastructure. So I think some of the goals were really set from day one, which were to being able to describe your infrastructure in plain text files, being able to put the same versioning that you put on your software, put on your infrastructure as code as well, and then being able to share that in your organization using libraries or modules, right? And when we think about like writing clean infrastructure code, there is a lot to unpack here. So I'll maybe take a stab at a few, and maybe Taylor can complete the other few topics that we might end up discussing in this. I think the initial portion for me in writing clean infrastructure code is to first figure out what you're trying to build, right? Like first figure out like what are you trying to capture and kind of create in your cloud environments or on-prem environments. Once that's kind of logically set aside, it's logically sketched up in a document or being able to like whiteboard it or so on. Then it's actually a one-to-one mapping once you start creating infrastructure resources to those logical units. It's often it's often really easy to write Terraform in terms of like it doesn't have too many complicated programmatic constructs, right? It does give you some programmatic constructs using HCL, things like for loops, if conditionals, and so on. But it doesn't actually give you too many things. And this is for a reason, right? We want to keep things really simple. We want to keep things that, clean in terms of understanding. If someone goes through it, someone parses through these resources, they should understand what you're doing, right? And we also don't abstract away too many things. So we don't say that, hey, you're creating a web server, but we actually expose what you're creating. So we actually expose things like, you are creating an EC2 instance, and you are creating a Google Cloud instance, and so on, right? So you know what you're doing in that perspective. So once you describe that with a really clean resource and being able to kind of cleanly logically divide the infrastructure resources, then you're able to kind of iterate over it over time, right? So the idea is to first like figure out like what you want to create, then figure out the type of resources that are supported, and then cleanly write that in code. So initially, a lot of people start with one giant Terraform project, and this is very common, right? Like you start with one giant, almost like a mono repo of Terraform files, and then you evolve it. So over time, a lot of folks go with two different strategic things. They might go and create like one project per service. So maybe you have a billing service, maybe you have a a stateful service. So you end up creating these independent infrastructure, Terraform projects. And then that basically makes up your infrastructure overall. But a lot of companies are going with, the monorepo approach as well, where you have one really big project with different, with different, segments in terms of like Terraform states. And you might explore some of the concepts as we go through this discussion. But the idea here is to kind of, start with a smaller approach. Start with like maybe one project that does a few different things. And as you see that you're adding like, as you're adding more and more projects, you have to be really carefully, design the system, right? You really have to carefully say, okay, at like 18,000 resources, this is becoming a really big Terraform project. So let's see if we can break that up into smaller segments and so on. And that might be based on business units. That might be based on the way you're laying out your microservices. So it's all up to kind of the user to do that. I think more recently, we've done a blog post on what works in terms of like the monorepo versus different and many repo approaches. I think and that's had a really good reception in terms of being prescriptive about what approaches you can take. So that's some of the background. I'll let Taylor kind of complete some of the things that I might have missed out here.
Absolutely. So no, and I totally agree with Mishra in terms of the that's the thing I think I see most too as people go through their Terraform journey, their infrastructure as code journey is creating that giant, main.tf file or repository, and just kind of like all of those dependencies, all of those things in there, which, at the end of the day is good, because you're taking that infrastructure that is, more iterative and more kind of like artisan crafted, by you via a GUI or bash script or some other processes, command line interactions, things of that nature. And being able to then take that and put that into a declarative form and format that allows you to continuously spin things up and spin things down, save money, adjust as you so wish, is really, that in and of itself is a really powerful thing. Being able to, stand something up in 5 minutes versus 5 days is just, immensely a powerful thing. Some patterns that I've seen started to emerge are just like Mishra said, where people have started to understand that, that's a good way to start. And then kind of the points in which you can start to break apart your Terraform code. We can have a networking layer. We can have a orchestration layer where we can spin up Nomad or Kubernetes or whatever we want. We can have a security module that's going to stand up some security groups that we might be able to use across different places in our organization or in our teams. And so that's personally something that I really like and have had a lot of conversations about recently. And then when it comes to, like Mishra said about the programming interface and kind of just enough to be dangerous, which I also think is really helpful. If you do want that full programming language type of experience and way to consume Terraform, then CDK for Terraform might be right for you, and kind of standing those things up and adjusting those workflows to what you need. But I like that you have functions and operations, like in the later versions of Terraform, we have for each, we have count, we have ways to iterate on modules. If we have a dependency that isn't tightly coupled or linked, we can use depends on to make sure things get stood up in the right fashion and in the right order. And then we have things like locals and dynamic values that we can actually iterate through. So depending on what kind of inputs you specify, you can then stand up some really, usually more complicated infrastructure. And so those are some really powerful things that you have at your disposal when you start using Terraform. And that's my recommendation, is take a look at some of the modules that exist out there and the ways that they're set up, as well as some of the functions that are available to you. Because honestly, I feel like every time I go looking through that documentation, I'm able to find at least like 2 or 3 new ways to do things. And it always, it makes my brain explode in a good way. When I go through that documentation, I'm like, oh my gosh, I can do that now. You can specify a CIDR, like a /16, and then create subnets, programmatically with a function that Terraform has. Things like that are just really fun and cool to find, in my opinion.
No, I think honestly, you guys covered an amazing portion of like uh, details there. But I'd also like to still unpack on this even further, right? I personally do love HCL, and I think the fact that it's declarative does help people to read it um, as an action step, which is fantastic. It helps people write clean code because it's already declarative. So you have a domain language, which is really nice. But let's unpack this a little bit more. I'd like to talk about dependencies, right? So how do you guys think people should manage dependencies between their modules?
Ooh, that's a good one. That's probably my second most favorite conversation to have around that, are just in terms of ways to not only version those dependencies, but kind of how to call out when these types of things are getting used. So one thing that one pattern I've liked recently has been you can set some I'm blanking on the name. You can set some custom validation. That's what it is. Custom validation within your variables. So if you want to use a certain version of something, or you want to only allow some kind of interaction to happen, like let's say I only want this kind of compute available, that is one thing that's really cool. But when it does come to, providers or versioning, ways in which your modules, interact with one another. Personally, I like a loosely coupled approach. Instead of is-a, I like has-a. So if you have a Nomad cluster, something I'm working on with the team right now is we want to stand up a Nomad cluster and make that easy. Rather than assuming that you are going to use that module to stand up a VPC, stand up a Vault cluster, stand up a console cluster, giving those endpoints to the module is a little bit better way to interact with things, and it keeps it, that means that you don't have to assume as much, and then you can kind of just expect, oh yeah, I'm going to need this thing, and interact with it that way. But when it comes to going back to the original question, when it really comes down to versioning everything, personally, I've also liked just very, very atomically setting those dependencies. So if I'm using Terraform 0.14.8, that's what I'm putting into my Terraform version. If I'm using, the Azure provider 2.5.2.0, as opposed to kind of putting something in there that tracks the major version and not the minor versions, just because, there might be bugs. There might be a certain way that the module is depending on some things that I might not anticipate. So I've in the past, I've kind of been okay with a major version, and then letting those minor versions rotate out. But the more that I've worked with different sizes and types of systems, the more static I try to make those dependencies, just because I have that certainty, that repeatability, and I can actually I can say, no, I've actually experienced, standing that up and testing that thing.
You said something that's, oh, sorry, Mishra, you want to add something?
Yeah, just going to add, I think, Omar, before we, discuss this, unpack this even more, I think some of the things that Taylor said are super, there are certain things that are super unique to Terraform. For example, you can specify a Git repository that has, your module. And what that means is you can actually specify a version of a certain module that you want to use. So I think in a lot of cases, I think I've seen this practice, and maybe this is just our industry, how it is and how we work, is that in some cases we are lazy, right? We just say that, hey, just take the latest of whatever that, that repo has, or we say that, just take the module that's locally available on Git, at this path, right? And you can specify the source of the module. That is, for most of you who know, who use Terraform, you can specify the source, and it could be a Git repo, it could be the Terraform registry, it could be a local directory that's in the same project or something like that. But I think a lot of people, find it very difficult when, things change. For example, when a module changes, let's say a local module changes, I'll give a good concrete example. So let's say you have your networking team that's defining a VPC module, right? That's creating your lower level kind of, backbone networking, and it's creating all things like ACLs and security groups and all the things that you need to actually operate in, for example, let's say AWS, right? And then a project is including that VPC, VPC module. And the way it includes it, it just says that, hey, like just take the latest of VPC or so on. And then you start iterating over that project. And let's say a few months pass and your infrastructure team changes the VPC module a little bit, that causes a bunch of breaking changes. There is no way of like kind of tracking that change, right? There is no way of being able to release it in a more defined way, right? So I think some of the things in terms of best practices is that you should be using versioning when you do depend on modules, and maybe you depend on multiple modules for a project. I think there's more needs to kind of use versioning in those cases. And then I think in terms of being able to structure things in a clean way, again, I would say try to simplify it as much as possible. Try to not do complicated dependencies when you have like 3 or 4 layers of module dependencies. I think in most cases what you'll find is you can actually simplify them by being able to create maybe rather than a smaller module, just create a bigger module that may avoid you to kind of chain them that way, because it really helps manage it for at least the infrastructure folks, and being able to manage it over time, because it's the same problems arises that you see in software, right? Like when a library changes, like it does cause a chain of reaction, especially a core library changing, especially in languages like JavaScript and so on, right? You know how that trickles down to every project that's affected by it. So I think ideally use versioning as much as possible, being able to create modules that have simpler graphs in terms of dependencies, and being able to describe things in a more simplistic form rather than trying to create some more complicated dependency situation that might come and bite you in the future.
I really like this a lot. But to even dig a little bit deeper into this, you guys mentioned like an atomic module, or saying that the module is kind of like doesn't have much dependencies and stuff. And what I'm kind of hearing out of this is the idea of like thinking of modules as a function. So how do we think of modules as functions, and how do we do like what we know in software as function composition, right, into Terraform with a declarative language?
Yeah, I think that's a good one. Maybe I can take a stab at it. So I think the way, at least like the way we try to present, at least like the way HashiCorp tries to present modules, and modules are really like, I think if you think about it, maybe a little bit higher up, even if you abstract the function a little bit higher, I think you would think about them as libraries, right? So you would define like a set of things that you want to do. So in terms of functional things, right? For example, you want to create a web server, right? Let's say you want to create a web server for your company, right? And let's say you're working for a mid-sized company that uses AWS, right? Now, what you can do is, as in operations, what you can do is you can create a module that gives, let's say, for example, developers a Java web server, right? That enables them to run Java applications on that web server. So you do all the heavy lifting in the background. So you define, okay, you need EC2 instances. You need to be including a VPC. You need to be, opening the certain ports that the web server runs on. Maybe you're creating an ELB on top of that web server, and maybe you're adding some EBS volumes to the web server, and so on, right? So you're doing all that work using Terraform in a module, right? And what you end up exposing to the developer is just a web server, generic web server module for Java servers, and you publish it, right? You publish it on Git, or you publish it on the Terraform registry or the private registry if you're using one. And then for developers, it actually, as you said, Omar, it does become functional, right? So for them, you're only allowing them with a set of inputs. You're only allowing them, for example, you're only allowing them to set how many servers do they need, the name of the server, maybe their team name, so that you can tag the EC2 instances, or maybe the port their application's running on, and maybe a few other parameters like that. That's it. That's all you're allowing them to do, right? So it becomes a very simple, input-output relationship here. So you define a set of inputs that your developers end up doing that, and what they get out of it is a fully formed, like your company's web server for running a Java application, which is approved because it's something that maybe the operations folks have put together, and they know best how to network and how to patch and how to basically configure that server And that just helps your developers because they get with their web server. It helps your operations folks keep some form of sanity in terms of what type of versions of Java and all the other packages that are installed on the server, how they're networking it, and in some cases gives security some compliance as well. You're not opening all the ports, you're only opening the ports that you really require, and this kind of ends up becoming a very functional relationship, and that's one of the more popular ways of using modules.
Thank you, Mishra. Yeah, that totally answers it. So let's divert just a little bit, and we talk about flat directory versus subdirectories versus workspaces. Let's unpack that. So please, guys, take it away.
I think that's a good conversation as well in terms of in kind of drawing from what we just talked about too in terms of the Terraform journey. And when you start using Terraform, you do try to kind of lump everything together. You get everything in one spot that's ready to go. And I think that one thing that's interesting, and one thing that I see often, this is my experience with Terraform, was kind of trying to put everything on Terraform to do, right? It's this cool new tool. I'm having a lot of fun using this and writing my infrastructure as code. So this should be able to do everything, including configure and set up this infrastructure and take care of all of the needs that I have as an operator. And honestly, I think that the more that you use Terraform, you see that that's not the case. Terraform is able to stand up, initialize, and get all of your resources ready to go. But when it comes to configuration, just configuration management, setting up your application workflows, you start to realize that there are some interesting lines to draw. And I do feel like that's where you can get that help with modules and workspaces, and then kind of understanding the problem you're trying to solve and how you want to go about solving that with a tool like Terraform. So some workflows that I've seen that makes a lot of sense in are around Kubernetes, for example. You could use Terraform to stand up absolutely everything that you ever wanted in your Kubernetes cluster, but at the end of the day, does it make sense? Or does it make more sense to stand up the cluster, maybe set some defaults, maybe set some ways that you're going to implement and use your storage classes and things like that. But then maybe you might want to use something like Argo or Flux to actually go about deploying things to your cluster. So I think it's a really important distinction to make as an operator on, where am I going to draw the lines when it comes to interacting with my infrastructure and with, the workflows that I'm going to manage. When it comes to workspaces, and I understand there are a couple contexts on that front too, when it comes to like a workspace with the CLI or, workspace in something like Terraform Cloud. In cloud, that's going to help, separate the context between what kind of, that mapping to your Terraform state, as well as kind of, again, like a network layer or an application layer, orchestration layer. What does that look like? And then when it comes to the CLI tool, I think that it makes a really good experience for if you have to, set up a dev cluster of something or a dev level of pre-production environment, or production environment. I want to change these values and kind of troubleshoot things and work with things in that way.
Thank you, Taylor. So something that you guys keep mentioning is like the growth of your Terraform code, right? And this is just the nature of things. As the company scale, pretty much they need to do some refactoring. So let's say someone is listening to this and then they say, okay, I want to go about refactoring my Terraform code. But they try to change one module name, and in the plan it says it will destroy everything because they have everything in one state file. So how do you guys suggest managing state and scale? And then we'll jump deeper into the technicalities of refactoring.
Yeah, this is I think this is basically one of the most common things that is asked in terms of like Stack Overflow and online like Twitter or like our own community forums. I think this is one of the most common questions, like how do you have effective state management? And for those who are new to Terraform, I guess I'll just quickly recap. A Terraform state file is really a way for Terraform to track the life cycle of a resource. So let's say you create a Amazon EC2 instance. once that's created, we persist the state of that resource in a file, or remotely in S3, or in Terraform Cloud, right? There's many different ways of storing things. There's other backends as well, like console and your databases, Postgres, and so on. So you can use multiple ways of kind of storing that state file, right? And what that allows Terraform to do is basically the next time, let's say you iterate over that server. So let's say you add some tags to the server. What Terraform does is actually, does a refresh of what's out there in the world that's running. So it first, understands that it is tracking that resource using the state file. It looks at what's running. It looks at the state file, and then it creates a diff for you. And that's what we call a Terraform plan, right? So that's what's going to be executed. So for example, in this case, when we do a Terraform plan, you'll see we're only adding the tags and that's it. And you'll apply that. So there'll be maybe like two or three things have just changed in that manner. And then again, that's persisted to the state file. So that's kind of the functional thing that the Terraform state file allows you to do, right? So now coming back to effective state management, and this is, like, as I said, it's the most common thing that's asked. So ideally, this is my own personal opinion, and maybe not the opinion for like a lot of different people. But what I've managed, prior to HashiCorp, I managed infrastructure for folks with about 100 to 200 developers that were creating hundreds of Terraform projects. And the way we were effectively be able to do that is really segregate things that are critical to the company. So for example, things that you cannot take downtime on. For example, creating your networking, backbone networking, VPC configuration, things like stateful things like databases and so on. Those I really recommend that you create separate projects for them, and they associated maybe with a workspace in Terraform Cloud, or basically a completely separate state file. That's not going to be changing that often, right? And then the things that are changing often, for example, your microservices that are coming online, you're changing different things to it. Maybe you created a microservice that was stateless, and then eventually you moved it to a stateful service. So you will end up doing a lot of work, and so there's a lot of churn to those Terraform states. Ideally, you want to disassociate those states from the states that are static, and mostly static, I guess, or are core to your system. So you don't actually end up clobbering that, and you don't end up corrupting them in any way, right? And it's a very infamous thing to say, is like a lot of folks here, like who have used Terraform for a while, have actually gone in and changed their state file manually and then fixed the problem, right? And I think ideally you don't want to do that. Ideally, you don't want to do that. That's not right. So ideally, you definitely want to segregate states. I'm definitely in the camp of creating multiple projects that are scoped really well, and that are completely separate from each other. And this, again, all depends on the way your organization is set up. It's really defined with how folks do operations, DevOps practices in your company, how you want to segregate these things, right? But I definitely recommend, do not try to, have one mega state file. And in which, to Omar's point, is if you change one thing, it's oh, I'm going to destroy 8 different other things, because the resources are all linked together in that way. Ideally, you don't want that scenario.
I've literally seen enterprises that do they have to use a Terraform taint approach, because if they change their Kubernetes cluster, that would take down their entire network, which we had some serious refactoring to do there, and that problem was fixed. So.
Omar, on the other hand, luckily, before you actually end up destroying all of your Kubernetes resources, this is why I think one of the reasons why I like Terraform is that you can actually see that's going to happen. So when you run a plan, you're going to do it. So at least you avoid doing that. Back in the day, right? I think when you did breaking changes like that, a lot of times you didn't realize that you've broken production or something until a customer or someone that is a user of your service has told you, hey, this thing seems to be down. You never knew what you've done, right? You would just change security groups based on your internal knowledge. So you would talk to the one operations person that understands how that service works. So you would just talk to them directly and be like, can I change the security group? And they'll say, yeah, I think it should be fine. and you change it, and then you realize that you've taken down production, which is unfortunate. So I think now at least you can actually see, before you're doing some of the breaking changes before you do them.
Terraform plan has literally saved the day so many times. Even honestly to like experienced Terraform people, because sometimes when you're using especially open source modules that you didn't necessarily read all the Terraform code that it exactly executes. You see one of the convoluted situations and you go like, oops, that will take down this entire subnet, which is not cool at all. So at least Terraform, as you said, prevents that. So let's shift gears a little bit. And this is a kind of an interesting conversation in itself because it revolves around automation with Terraform, right? So Terraform itself is built around this concept of infrastructure as code was initially to help with automation. So where does CICD fit in the picture? And can we ever put Terraform in a truly autopilot?
That is an interesting question, Omar. I'd say that when it comes to CI/CD, I've used Terraform in a few different ways most recently, and I do like having it in a pipeline approach where I'm either able to have a repository and then pick up changes off of main and enact those and have those go to the moon to production and enact this. I'd say but it is interesting when it comes to infrastructure versus code. There are many differing opinions on ways to set up your Git branches. Me personally, I like trunk-based development, and then when you tag something, make that the release to production. That's my personal flavor of development that I really like. And when it comes to infrastructure, it's very difficult to test and to stand up in most contexts. I do like how we have Terraform plan and that ability to make sure everything is going to be as we expect it to be when it's time to actually apply. When it comes to Terraform Cloud or GitHub Actions, those have been my two most favorite ways of enacting and planning and kind of watching things move their way to production with my demos and with different things that I've worked on. So I really like that approach. I don't really ever think that we'll get to that no ops place. I feel like you can reach a level of comfort with the code that you write, with the modules that you create, and the ways that you decide to put those together. But I do think that you will always need, at the end of the day, that something isn't going to work out as expected, and you're going to need somebody to come in and take a look, troubleshoot, and kind of, kick the tires on what you might have stood up. But I think we are getting to a better place and to getting more ability to statically lint on things when it comes to Terraform. I've really had fun working with others on GitHub Actions and different types of workflows with Terraform that we'll go through, run a Terraform validate, run a Terraform format, and make sure that you don't have any typos, all of your syntax checks out. And then, as people open up pull requests and other things, I think that's just a great way to stage things and kind of make sure that you're not putting any bad code up that might work its way into production. I've been a big fan of Terraform Cloud because it has that ability built in to, you could turn it off, you can make it automatic and just kind of like push thing YOLO mode where you're just kind of pushing that stuff to production. And but I do like that, you can have that after a plan runs, if everything checks out, have a team member say, oh, all this stuff looks good to me, go ahead, and then actually push that to production. So I do like those gates and just those checks. If there's a way that we can, through future iterations, make that a little bit easier, or write some, unit tests, contract tests, things of that nature, to have a little bit more certainty, I think that'd be great. But yeah, for now, I do like that check and like, okay, this plan looks good. I'm not deleting all the VPCs or all of my network spaces or anything like that. So personally, I like that right now. But I think we'll get closer to that no ops, kind of flavor. But I don't think that we'll ever 100% get there.
Yeah, I guess I agree with Taylor. I partially agree on certain things, like that eventually it's going to be really hard, right? I think like this whole idea of like when people talk about no ops, like I think It's unfortunate, but like I think the reality of the situation is that eventually there is a human that does something. It's of course we try to avoid that by automation and being able to promote things in a CI/CD system and things like that. But I think especially for infrastructure, right? This is a little different from software, right? Like in this one particular category, because there should be some into human intervention, as Taylor said, to basically keep some form of check in terms of doing really like different or I guess like crucial infrastructure operations. I think in some cases, though, Omar, I agree with you. I think we should try to see ways of being able to just not even review things and just push them to production. But I think for that, again, you need to build confidence, and that comes from testing, being able to, as Taylor said, being able to create test environments to test infra like regularly, and doing that in many companies are doing this, right? Like a lot of companies, for example, use Terraform Cloud or GitHub Actions and so on. And when someone creates a pull request, they actually go through in applying a few different resources and doing some sanity checks. People are using things like TerraTest. That's a project by Gruntworks, and things like that to enable that confidence. And that should be good enough. But if you're still treating like infrastructure as code, you will eventually come to a review phase, right? Like in GitHub, like maybe creating a pull request or not committing to master directory. Like those type of practices are also in software. Right? So I think they should remain in infrastructure as well. But then on the other hand, there are technologies, for example, like Kubernetes or Nomad, that allow you to do some form of reconciliation where you have a state, you have a declared state, and you have a present state, and you want to get to that declared state, and you do that in an automated fashion. So I think that in that case, I think things like GitOps come into play and stuff like that, where folks treat Git as a source of truth, and there are some reconciler groups that just make that happen for you. And I think that is I think the right way forward for things that pertain to automation. But again, there has to be a source of truth. There has to be a defined process. I don't think we'll ever get to a place in infrastructure where the best practices is free for all, or the YOLO technique where you just go and apply whatever you want, right? I think ideally you don't want to, we're not going to promote that because we know that does have disaster consequences. Whereas on software, I think in some places people just get away with it, right? I think we've done that in the past by just SCPing like PHP files on a running web server and like just reloading things and seeing what happens, right? And we've done that in the past. But I think with infrastructure, like the rollback, for example, like in infrastructure, like a rollback has more consequences than a rollback on the software side. So for example, like you end up doing like a database deletion operation in the cloud, right? It's going to take, like on Amazon, let's say it's going to take like 10, 15 minutes. You're hard down during that time. Then let's say you start bringing up another new node to enable like some form of failover to a new node. That's going to take another 20 minutes. So it's, every operation can really have disaster consequences. So you really need to be careful and go through that plan process and review and validate. And in some cases, you can probably achieve it without doing those type of things.
So, like, what rail guards can people add to prevent mistakes like this, right? Like, I know the life cycle, like prevent delete for a database, for example, maybe would fit in this criteria. But what other tools and insights that you guys would suggest to people to do to prevent mistakes like that?
I think one of the fun gotchas that I've come across most recently, within the past 2 weeks, honestly, are discussions I've had with people around again that like only put into Terraform that which you really want to manage. So there was somebody I was talking with where their use case involved like Mishra said, changing these things in flight, changing these production applications and auto scaling groups, within Amazon as an example. For those of you not familiar with that, it's basically the ability to spin up machines and then rotate them out, scale up, scale down, and et cetera. and someone had set that up where they put in a desired state. And so they were doing a whole bunch of calculations and trying to figure things out, and then using desired state within their Terraform module. And that's what you don't want to do, because if you have 20,000 or 10, or I mean, even 4 machines that you have running within an auto scaling group, if you reset the size back down to 2 or 1 or 0, you can get yourself in trouble because those things are operating. So kind of being cognizant of things like that too, like this is something I don't explicitly want to control with Terraform. I can set a min and a max, and that should be fine. I can ignore the desired state in certain contexts. So that's definitely one gotcha that I'm always happy to share. I think the more that we can share that within our communities and with the community as a whole, the more we can work those kinds of concerns into the different modules and types of things that we create. But I think that again for me is the biggest one, is just kind of being aware of the context. And while it's good to define as much as you can, you don't have to, have one tool kind of have dominion over just about everything.
Yeah, I think, and the one other thing I would add is that being able to actually use the cloud how it's intended, which is, as Omar, you said, right? Being able to do things like, protect, maybe termination protection on your instances, or for auto scaling groups, maybe having a scale in, scale out policy that doesn't do things at just the default way, right? Just try to read a little bit more on the services that you're using in the cloud, and just utilize what the best practices are that are prescribed by the cloud provider in the cloud cases. Because the reason why I say that is because we are in a very different world now, right? One API call can really take down a whole company, right? And it's dangerous, right? This is why there are so many different type of guardrails that every cloud provider provides you. They say, hey, don't run everything in one account, right? Or don't run everything in one project on GCP, and so on. Try to segregate that, and make sure your keys are not being committed to Git. There's bots that are going to find your AWS keys right away and start creating resources on the cloud. And I will not deny, or I will not deny this has happened to me. I don't know. This has actually happened to me at my previous employer, where not me, but someone had committed keys in, and people are creating hundreds of instances in Australia where we never operated in AWS, but things like that, right? So I think you really need to really use the best practices that your cloud provider is prescribing you, and then just implement them. Use Terraform as a machine to implement those best practices in code, and maybe do things like, for example, Terraform has a really nice feature where you can actually get the JSON plan output rather than just what you see as an operator. You can get a JSON plan output. Maybe you can write something very, very simple that parses that JSON output and does some form of guardrails. It actually checks for, let's say, opening ports to the world, or being able to, enforce termination protection. So in your CI/CD pipeline, just fail that plan, right? Just say that, hey, this plan's actually not successful because you don't have X, Y, Z. Or you can use, or if you have kind of the money or the finance for it, you could use things like HashiCorp Sentinel. That's part of Terraform Cloud offering. It allows you to do some of more, fine-grained things, which are more sophisticated and first-class into Terraform. So yeah, there are many ways to do this, but I think the start for anything in this case is using what's out there in terms of the cloud provider's best practices, and doing things that are sane for the infrastructure, and then implementing them using Terraform.
So does Sentinel parse the JSON essentially, or sorry, I meant to ask, does it actually come with the Terraform Cloud? Is that part of the offering for the Terraform Cloud, or is that a separate product?
Yeah, so I think means, again, Tylor and I really operate in the open source side of things, but I think I'll try to answer this given I think I joined the company around when Sentinel was released. So the Sentinel is basically a policy as code language. For those of you who don't know, it is part of the It used to be the part of HashiCorp enterprise offering, the Terraform enterprise offering before Terraform Cloud. This is when we offered it on-prem, and you would use the Terraform enterprise. Just the instance would be running on-prem on your location. So yeah, so basically it's an offering that was then moved to the Terraform Cloud as well. So now for certain pricing tiers in Terraform Cloud, I don't think this is included in free, but I think definitely for certain other tiers, I don't know which exact tier this is. You can look it up. I'm sure this is online somewhere. But yeah, basically it's part of the one of the paid offerings, and gives you a first class step inside your Terraform Cloud. So for example, your general Terraform workflow is Terraform Plan, which you can see, then Terraform, maybe Terraform Apply, right? With the Sentinel policies in, you'll get like maybe 3 steps. So you'll have a Terraform Plan, then you'll have a policy as code validation step, where you can define policies in just very simple English language, really, because Sentinel is targeted towards the policymakers that are often in larger companies that are often not technical. So that's why the language itself is written for folks that can describe it in a really, really simple way. And then you go ahead and apply if that policy checks passes. So you can do complicated things like, hey, don't do a deploy, on a Friday at 5 p.m., right? So you can define policies like that using Sentinels, and you can do a lot of different policies with Nomad. You can do, with all the other HashiCorp products as well. So it really first class integrates with Terraform, not only Terraform, but other HashiCorp projects as well.
Awesome. So Tylor and Mishra, thank you so much for giving us these amazing insights. It's very important that we bring the community more frequently together. I think what I'm really was hoping to do with this talk, and I think this has helped definitely a lot of people, is that giving platform engineers some extra sleep, right? Because they don't have to destroy their entire infrastructure. So thank you very much for providing these insights.
Yeah, absolutely, no problem. And I don't know. I have to check with Mishra. I don't think we have a sleep provider in the industry, but maybe one day. Maybe one day.
There is a Domino's pizza provider.
Thank you guys so much. I hope you have a wonderful evening, and thank you all for joining us today.
Thanks so much.
Thank you, everybody.